thank you for the opportunity to present to you in Storage Field Day. Great to see you. So today I wanted to take you through a technical deep dive of CTERA's technology. And let's start by discussing in a very high level what is CTERA technology. It's a global file system. A global file system is a file system that exposes a single namespace that's accessible from anywhere, from multiple locations, edge locations, and cloud locations, and exposes a single namespace. In CTERA implementation of the global file system, it's multi-cloud. So as Liran mentioned earlier, you have the ability to connect to multiple cloud providers at the same time. So in this example, you see a private vSphere on premises. You see an AWS US East 2 bucket and another object storage bucket in Azure. You could have any amount of buckets that you want, either on premises or in the cloud and in different regions without any limitation on the amount of latency between them. And it's 100% private, meaning that we don't have any shared components, SaaS components, and that makes the solution usable for very security conscious customers that are not willing to have any shared components. We also have a SaaS option, which is mainly used for smaller deployments, but the vast majority of our customers use the 100% private solution that's fully deployed in their private cloud. Just like we have support for multiple clouds, we have support for multiple different kinds of clients. So we have the edge filers, which are replace NAS devices or Windows file servers and expose the SMB or NFS interfaces. And we have the agents or the mobile devices, which allow you to access the same information for remote users, users that are working from a plane, users that are working from home. They have the ability to connect these agents or mobile devices. And the one important aspect here is that you should understand is that the agents and the mobile devices are first-class citizens of the global file system. So they don't connect to the edge filers and from there to the global file system. They connect directly to the cloud, and they don't rely on edge filers. I wanted to talk a bit about the consistency model, and we got this question earlier, and I wanted to discuss it. So the consistency model of the global file system is what we call the hybrid consistency model. So this combines strict consistency and locking when you're in a single site. So when users are at the same location and there's no latency between them, they have strict consistency and each one sees the updates of the other user immediately, and locking is supported. When we talk about communication between sites, the model is eventual consistency, which is without locking. And the reason for this is scalability.
So Aaron, a site in this case would be like an edge filer or multiple edge filers potentially, or agents or mobile devices.
Yeah.
I'm just trying to understand what the concept of a site is in this respect.
Yeah. So a site is a device. In case of the edge filers, for example, in our X series edge filers, they come in as a cluster. So we have multiple edge filers and they're a single cluster. But in general, yes, it's a device. Okay, so an agent would be a separate consistency domain from an edge filer. But all the users on an edge filer, and there can be thousands of them, they have a strict consistency between them. And why did we choose this approach? There are some reasons to have strict consistency between sites. Of course, inside a site it's very important, but between sites, it's not a very common requirement. Mainly, when customers want that, they're using software such as Autodesk Revit for CAD, which is a very specific use case. And in fact, Autodesk already, they have other solutions for collaborating between sites. and customers are relying less and less on having this kind of global file system for Revit. So it's not a very common requirement, and it has a very, very heavy cost. So when somebody tells you they support locking between sites, usually they say that it works, up to 5 sites, maybe 10 sites, in the best case. But it really doesn't work when you have hundreds of sites or more, and it doesn't work at scale. And the reason is the latency. So of course, when you're doing locking, you need to go to a centralized locking server, and this significantly reduces the performance of the system, especially when you have high latency between the sites. So since we need to have, and our product is designed for very high scalability, we do thousands of sites, hundreds of thousands of agents that are connected concurrently, and we want to provide all of them land speed, so we don't want them to feel the latency, and we want the system to tolerate network failures. Based on the CAP theorem, it's really a trade-off that you have to make. And the trade-off here is that eventual consistency across sites, it means that there could be conflicts, similar to what you might have with OneDrive or solutions like that. But in real world, in 99% of the cases, this is what's needed, and it don't pay the price of the strict consistency across different sites.
So for a real world scenario, let's say I work from the office and at home equally. What makes more sense? Should I use the agent only? Should I jump between the agent and a share depending on where I'm at? What would make best use of the technology there?
So for work from home users, we have the CTERA Drive, and it's very common for home users to have CTERA Drive on their home computer, and when they're in the office, work with the Edge filer. So that would be the recommended combination. Okay. We usually don't recommend using SMB over VPN connections, because that doesn't the SMB protocol doesn't work well, and you will not enjoy that. Many applications are not designed to work over latency, and they work very, very poorly. So typically we do recommend installing the agent on your computer.
Okay, thank you.
I have another question. What happens if you work on a file on 2 locations at the same time, so you get a conflict?
Yeah, so thank you for the question. The answer is that you will get a conflict file. So you'll get another copy of the file, and would say conflict by Rob at this and this time, and you will have to resolve it. One of the things that Shannon showed in the demo is that you can use co-editing in Office 365. When you're using the co-editing, then there are no conflicts. Everything is in real time. 2 users can edit at the same time, and there's also no locking, because both of them can edit and they see each other's edits. So the way the world is going, we're seeing more and more co-editing and less locking. It's becoming more, much more frequent. It's much better user experience for 2 users to be able to see each other's edits rather than lock each other out.
Okay, but it still can happen, and if it does happen, you see it because there's a second file that's being created.
Yeah, so if you use the traditional approach without the co-editing, then you may get conflicts, and you will have to resolve it.
Okay.
Yeah. Essentially, you can think about it as you're checking in 2 code versions, right? 2 people on GitHub trying to commit 2 different branches that might have a conflict. I think this summarizes it. And just to touch on David's question too, one of the factors, of agents and filers, typically the considerations we have with many of our clients, if these are very small sites with a very small number of users, they typically like to go software only. The overhead of having a local appliance or even virtualization is something that they might want to avoid, especially if the footprint of data is very small. The filers come into play very well when you have sites that are larger in terms of users, application needs, and capacity needs as well. But one of the unique things that we could do is that we can combine both within the same single namespace. So the customer has the choice of incorporating both into the solution.
Yeah, and one of the great things is right this year we released the HC100 device, which it's a really tiny edge filer. It's the size of a mobile phone more or less. Has 1 terabyte of cache, and that's good for power users. Like if you're a video editor and you want to edit, 500 gigabyte movie, you typically would get this HC100. Or if you have a small work group of 5 people, you would get this HC100, and actually offers very good performance with NVMe flash drive, and that's a great solution for this kind of small work group. Okay, so taking it a bit further. So when you have great, high scalability in large number of clients and users, we see more and more complex data management requirements. We consolidate, tens or hundreds or thousands of filers into this global file system. Things are complicated, and some complications include things like data sovereignty or compliance, where certain countries, for example, require you to store certain data inside the country, right? So let's say financial reports for a company traded in Germany needs to be stored in Germany. So in order to do that, we have a data placement policy, which is optional. You don't have to configure it, but you can. And you can define that specific pieces of the data, like folders based on a folder level or based on the location where the data was written. You can decide that they will be written into a specific cloud data center or private data center, right? So you can say everything that comes, every financial document from a finance share that's written in Germany, write it in AWS Frankfurt site, right? So this allows you to control it with very good granularity where you want to store everything. And the second benefit of this is data locality, because if you have specific pieces of data that are frequently accessed from a specific location in the world, it's much better to store the data close. So this is really a comprehensive approach for multi-cloud, where you can use all the clouds concurrently. You can use the on-premise concurrently. You have top secret data, send it to the on-premise data center. If you have something that's okay to store in the cloud, send it to the cloud. You can do everything at the same time. The second, and this works also together with the security zones. And the security zones are a bit from the other side. You have some information in the global file system, and by compliance or by your security requirements, you don't want to expose this data in specific locations. For example, let's say you have a GDPR controlled file containing or healthcare file containing patient information from patients in Germany. By regulation, you're not allowed to have users in your employees in China to access these files. So you can define security zones, and you could say this folder is restricted. You tag it with a specific tag, and you say this is a restricted folder. This folder may be accessed only from Germany, or from a specific amount of filers in specific locations. And another great thing about data management in multi-cloud is that we offer you the data mobility. We allow you.
So Aaron, back to the prior, the security zone. What about agents and web access and mobile access and stuff like that? Is that so? If I'm sitting in Germany and I move, to Hawaii or something like that, does my access with respect to those security zones change?
So the security zones are for shares that are shared
filers only.
And for end users, there's a different mechanism where, as you saw earlier, there's a shared with me folder, and the administrator can control what they want to share with specific groups of people. So this doesn't move according to your location, moves according to your groups in Active Directory. So based on your groups in Active Directory, I can assign to you specific folders or specific projects that I want you to be able to access. So
for example, Yeah, and just to add to Aaron, and I think Ray, you mentioned something that in that 100,000 user deployment we mentioned before, they have a scenario where they have a shared staff, a person who could be staffing 2 different agency offices, and there's a shared folder for each office. So when you're in office number 1, you might need access to that, but sometimes you need to access a different folder. So we provide that ability. It all ties back to access control and AD and permissions for you to be able to map those folders and be able to support, the Hawaii and Amsterdam or so on.
All right, thanks.
Yeah. Okay, so about the data mobility, one of the most painful things in moving to the cloud is that it's very difficult to move out, right? If you put your data on S3, you're pretty much married to Amazon for the next years, and that's not a good place to be, right? When you have one vendor, you're locked to them, you can't move, they can charge you whatever they want, and even if there's a new cloud provider that's much better and much cheaper, it's really impossible for you to move. But we solve this by having the ability to transparently move information across the different buckets or across the different clouds. We have a tool inside the portal where you can simply click on on specific portions of the data and say, I want to move this to a different cloud provider. And this performs an operation in the background. It could take a very long time, right? If I want to move a petabyte of information, it could take a while. But while this transfer happens, the users are operating normally. So because our solution is multi-cloud and all the edge filers, the agents can talk to multiple clouds at the same time, they simply fetch the pieces of information based where they are now. So things move on the block level, right? So nobody connected to the edge filers or the agents notice that this transparent movement is happening. And this is really a game changer because it allows you to avoid lock-in to a specific object storage or cloud storage provider. Now let's talk a bit about the edge filers. We have as we mentioned earlier, an edge filer is a device that exposes from one side SMB or NFS. In our case, it's NFS3 or NFS4. And on the other side, the backend is an object storage. Now we support a very wide variety of edge filers, and they vary from one terabyte. The HC100 that I mentioned earlier is just 1 terabyte, up to 128 terabyte, which is the media gateway that Liran was talking about.
So Aaron, where's the portal in this description? Isn't there a portal involved here someplace?
Yes, there is. This picture is simplified, and
okay. All right, thanks.
The nice thing, and I'll talk about it in a few in a minute, is that the device the edge filers really talk directly to the object storage, but I'll get to that in a minute. The edge filers. So we have the HC series, which are like your traditional. They look like your traditional servers or NAS devices. And you can run some a few little virtual your own machines on them. If you have like Active Directory, we still have some space on the HC appliances where you can run your own DNS server or Active Directory if you want as a virtual machine. And we have the X series. The X series is a hyper-converged appliance. So it comes as a cluster of multiple devices. It's all flash and highly available. So if one of the nodes fails, then you have a local backup of everything, so you don't have to fail over to a different edge filer. You can use the single edge filer has high availability. And in addition, this is ideal for cases where you want to run heavier workloads at the edge. The X series has pretty much a lot of spare capacity. It has 256 gigabytes of RAM, so you can run pretty heavy workloads in addition to the file serving capabilities, and really consolidate all the infrastructure of a specific site into one little cluster or box. In addition to the hardware that you can buy from CTERA, actually most of the customers buy the virtual appliances. And we really have a very wide variety of places where you can run them, and it's not easy, I could tell you. They can run. You can either run them on premises, in VMware, in KVM, Hyper-V. You can run them in the cloud. We have editions fully certified for AWS, for Azure, Google Cloud, and IBM Cloud. You can run them on hyper-converged platforms, Nutanix, SimpliVity, HyperFlex, and soon we're going to have the Kubernetes edition, which will allow you to connect Kubernetes clusters into a global file system. So that will be very interesting, and we will. I'm sure we will talk about this more, in the next few months. Now, I'd like to talk a bit about the difference between caching and tiering, because this is often confused. The idea of tiering is to move stale data to the cloud. And moving stale data to the cloud is great. But notice the word move. You move the stale data to the cloud. In caching, you keep everything in the cloud. The cloud is the golden copy of all the data of your company. And some of that data, which is hot data, is cached locally on the site. Now, both of caching and tiering are great for capacity expansion. You can have a 5 terabyte appliance and connecting to 1 petabyte of cloud storage. So that's really useful. But this is where the similarity ends. Because the golden copy is in the cloud, caching allows you much more use cases. So one of them is disaster recovery. So when you have a caching gateway or caching appliance, if your device fails, all you need to do is to spin up a new virtual machine, a new caching appliance. It will start up with an empty cache, but immediately users that are connecting to this device will see the information from the cloud, because the metadata is downloaded in real time as they're requesting it, and it will eventually warm up to be a warm cache, and provide 99.9% hit rate for the cache. So you will start with slower performance where you have more hits to the cloud, but it will warm up pretty quickly. And we also have tools for intelligent warming of the data, where you can.
Aaron, the big challenge with caching versus tiering is latency. Depending on where the physical data resides in the cloud, the latency can be multiple hundreds of milliseconds, et cetera, et cetera. If it's tiered, it's directly accessible as long as it's not stale, quote unquote, cold data, right?
So caching and tiering are the same in this regard. Where they work, caching works in very high latencies. When you try to access information that's stale, right? That's not available locally. It will go to the cloud and fetch it, and then you will have this penalty of the cache miss. And it's the same for tiering. Yes, caching.
But, typically, tiering is only the data that's considered cold or stale, whereas caching is limited to the amount of cache space available in a local edge filer cluster or whatever, right?
Yeah. Also, the tiering is limited to the amount of storage that you have in the device, and the stale information is based on the amount of things that you didn't access for a while. And caching, in at least in our implementation of caching, it's pretty much an extension of tiering. So we synchronize everything to the cloud, and things that are warm, so I'm meaning that they're not stale, you keep locally. You can have them pinned if you want. So if you have everything pinned, you can have everything available with local capacity, but of course you will not have enough space to pin everything. So so essentially tiering and caching is an extension of tiering in this regard. I hope I made myself clear.
So Loren mentioned your direct I/O mode earlier as one of the capabilities that allow you to be 3 times faster than cloud gateways. How does that play into this discussion?
So let me go to one of the next slides, and I'll
fine.
Yeah. Okay. In addition to disaster recovery, because everything is the golden copy is in the cloud, the local device is just a cache. So disaster recovery is simple. Cloud bursting means that if you generate information at the edge, let's say that you have video or visual effects editors that create some content locally, the artists, and they want to do large renders in the cloud once every week, right? So they would create all the data locally, and then once a week, they will spin 1,000 machines in AWS. These machines will connect directly to the global file system in the cloud by means of another filer in the cloud or by means of the Kubernetes container that we are now developing. And they will do this big number crunching to do the visual effects rendering and write the results back to the global file system. And then you can stop these at 1,000 machines, and the users on site see the results. So they get this capacity of compute power and this dynamic extension of compute power based on being able to have a shared file system between the cloud and the local on-premises users. And finally, the cross-site collaboration, which is not possible with tiering, because with tiering you have one device connected to one bucket, moving part of the data. With caching, you have all the data in the cloud, multiple accessor devices. So cross-site collaboration is easy. Every user sees the edits of the other users. Now, talk a bit about under the hood and getting to your question about the direct protocol. How does it work? So we have the portal. The portal is this orchestration system in the cloud. It's on-premise. It's private to your company. Typically, it's not something that's shared with other CTERA customers, and it consists of multiple application servers. The amount of application servers is horizontally scalable, so you could have as many or as few as you need for your amount of load. And there is a metadata database, which is replicated. So for high availability, we have a pair of metadata databases that are replicated to 2 different locations. And the metadata database contains everything that's not the data. What do I mean? The names of the files, the names of the folders, the ACLs, the usernames, the configuration, everything that's not the actual data. So where is the actual data stored? In object storage. Okay, so the data is broken into blocks and stored into the object storage. So we have this separation between the metadata and the data, which are stored in different locations. All the data is stored, it's encrypted in the object storage, and the keys are not in the object storage. So anyone who looks at the object storage cannot read your data or understand what's written there. The keys are written either in the CTERA Portal, which when it acts as a built-in key server, or you can connect to an external key management server using the KMIP protocol. So this is how the information is stored in the global file system. And now we have the clients. So we have edge filers and agents, which connect to the application servers of CTERA Portal. They connect to them using a protocol called CTTP, CTERA Transport Protocol. This is a TLS-based encrypted binary protocol, which allows very efficiently to communicate and send information back and forth between the client and the portal. When we talk about the mobile device, it doesn't use CTTP. It uses HTTPS and a REST interface. And this REST interface is also exposed as an API that allows you to develop your own applications on top of CTERA Global File System. When a new file is stored to the object storage, it's divided into blocks. And as you see here, each block gets a hash. The hashes are sent to CTERA Portal, and the portal looks up in the metadata database, which has a blocks table, as you can see here. And this blocks table tells the portal which blocks it already has and which it doesn't have. And if it has, it tells where this block is stored, in which cloud and in which bucket. And if you can recognize this as a type of source-based deduplication, because every block we store, even if we have multiple files using the same block, we store it only once. Okay, so there's never the duplication between the blocks. Then the portal, after looking in its database, it responds for, I need these blocks are missing. But it doesn't just return the identification for these blocks, it actually produces signed URLs. It creates URLs which are signed with a key that only the portal knows. And these are the URLs that allow the devices to write into the buckets. Without this signature on the URL, the filers don't have any credentials for the object storage. They have no ability to write anything or to delete anything or to do anything in the object storage. They can do only things that the portal as an orchestration layer allows them to do using these pre-signed URLs. And the reason the performance is very high is because the filer can go directly to the buckets. It doesn't have to have the portal in the data path. It goes directly to the bucket, and the bucket is typically near the device. It can write the information directly there, and it does it for many blocks in parallel. So it can use up to 100 concurrent threads, and it can write up to 100 concurrent blocks at the same time. So this pretty much saturates any size of internet connection that you will typically have for the filer. Now, why is this important? As I mentioned earlier, the theme of CTERA's technology is scale. We want to work with 100,000 concurrent users that are connected individually to the cloud file system, and thousands of edge filers. And we have customers with thousands of edge filers. And in these cases, you always have one at least that is compromised at some time. And so scalability is not only how to work quickly, it's also the security architecture needs to match. So CTERA's architecture is a zero trust architecture where we don't trust the edge devices. We never provide privileged credentials to these devices so they can access the object storage. If we would do that, the compromised device would just connect to the object storage and delete everything, and you don't want that. So it's much more secure. It's not in the data path. It's much faster, and it allows this multi-cloud approach that is both very efficient and transparent when it can work during migrations between the cloud, because the portal is orchestrating all the data transfers. So I hope this answers the question about the performance and the scale. Summing up in a nutshell, CTERA, our technology is enterprise NAS, global file system over object storage. So you enjoy the scale advantages and price advantages of object storage. It's 100% private, so it's suitable for the most security conscious customers. We have no shared components that the filers or the portal connect to. It's a multi-cloud, natively multi-cloud solution. It implements a hybrid consistency model comprising local strict security, strict consistency, and eventual consistency between sites. It has the ability to do data placement policies, mobility of the data between the clouds, and it implements caching and not tiering and the zero trust approach.